Hello everyone, myself Mrs. Shailaja A, Assistant Professor, Civil Engineering Department, Walchand Institute of Technology, Solapur. In today's lecture, we are going to study analysis of pin jointed plane frames. At the end of this lecture, the students will able to determine the forces in all the members of the truss by using the method of joint, and the students will able to determine the zero force member in the truss. So these are the various methods that we will use in the analysis: method of joints, method of section, and graphical method. Now we will see how to find out the zero force member in the truss. Zero force member means the member which will not have any external force in itself. Okay, so here we can find by two members method and three member method. So if you observe this truss at joint C, this member DC and member BC are not parallel to each other, and again we don't have any external load on this joint C. Okay, so here we can call it as a force in member CD is 0 as well as the force in member BC is 0. Then three member system. If two members are parallel and there are no other external loads acting at the joint, then non-parallel member is called as the zero force member. For example, if you observe this truss, this member BC and the member BD are parallel to each other. Okay, so and again we are having no external load at joint B, so we can call it as the force in member AB is 0. So likewise we can find the zero force member in the truss. Now we have to find out the forces in all the members of this entire truss. First of all, we have to find out the inclination of this truss. So here I will tell it is theta 1, here it is theta 2, and here it is theta 3. First I will calculate this theta 1. So here we can consider tan theta is equal to y by x. So 4 by 6. 4 by 6 means this entire triangle I have considered. Okay, so here we will get theta 1 is equal to 33.69 degree. So here we will get theta 2 is equal to 8 by 3 into n by 2 is equal to, here it is tan inverse of this, so we will get theta 2 is equal to 53.13 degree. Okay, then theta 3, here we will get tan inverse of, it is 4 by 3, so again here it is theta 3 is 53.13 degree. So first of all we have to find out the reactions of the truss given at this support. Here it is the roller support, and at support B we are having the hinge support. So here we will get two reactions, that is vertical reaction as well as the horizontal reaction. Okay, so the external forces are acting at joint F, that is 12 kilonewton, and joint H it is of 20 kilonewton. So if we observe the entire truss, so there is no horizontal forces, so we can write the horizontal reaction HA is equal to 0. Now we have to find out a joint where we will get only two unknowns and one known force. So if I consider this joint H, here I will get two unknowns and one vertical force. So if I draw the free body diagram of joint H, it is external load is acting of 20 kilonewton. I will consider the nature of force HF as a tensile, then the nature of force in HG also tensile force. Okay, so first I will consider summation of vertical forces is equal to 0. Okay, so it is minus 20, then component of these two force, this inclined force, it is minus FHG sine theta 3 is 53.13 degree is equal to 0. So from this equation we will get force in Hg. So here you will get the force in Hg, it is 25 kilo Newton. Okay, so here you will get the negative value. So what it means, whatever we have assumed the nature of force, it is opposite to that. So here I have assumed it is a tensile force, but we got it is a compressive force. Then we'll consider summation f of x is equal to 0. So what are the horizontal forces? That is minus force in Hf minus force in Hg cos 53.13 is equal to 0. We will get the force in Hf is equal to 15 kilo Newton. So here we will get the positive value. So whatever we have assumed the nature of force, it is correct. So here it is the tensile force. We will calculate the reaction Rg. Okay. So I will consider the movement about point A is equal to 0. So if we consider movement about point A, this 12 kilonewton force is acting in clockwise direction, so it is positive. 12 into what is the perpendicular distance? It is 6. Then again this 20 kilonewton force is also rotating in clockwise direction. So here it is clockwise movement. Again this vertical reaction Rg, it is rotating in anti-clockwise direction, so it is minus Rg into 6 is equal to 0. So here we will get reaction Rg is equal to 42 kilo Newton. Now I will consider sum of all vertical forces is equal to 0. What are the vertical forces? It is minus 12 kilo Newton, minus 20, this vertical reaction Ra and the vertical reaction Rg is equal to 0. So from this equation Ra we will get minus 10 kilo Newton. Minus 10 kilometer means it is acting towards the downward. Okay. Now I will consider joint A. So if we consider joint A, what is the free body diagram? It is the vertical force Va and the horizontal force Ha, then the force in member AC, and again I will consider the nature of force in member AB as a compressive. Okay, so first I will consider sum of all vertical forces is equal to 0. So here it is minus Va, again the component of this force AC, it is minus force AC sine theta 1 is 33.69 is equal to 0. So from this equation you will get the force in AC, we will get here minus 18.03 kilo Newton. Okay, so here I have assumed it as a tensile force, but we got it is a negative value. It means we will have the nature of forces compressive. Then I will consider sum of all horizontal forces is equal to 0. So what are the horizontal forces here? It is HA minus force in AB, then plus force in AC cos 33.69 is equal to 0. So HA is horizontal force, horizontal reaction, it is 0, then minus force in AB, then plus force in AC. Here we got minus 18.03. So we will keep with the sign convention. It is cos 33.69 is equal to 0. From this equation you will get force in AB is equal to minus 15 kilo Newton. Okay. Then next I will consider joint B. So the free body diagram of joint B is, what is the nature of force AB? It is tensile force. Okay, it is the joint B. so it is the force in BA. Then I will consider the nature of force in BC. BD is also a tensile force. Then I will consider the nature of force in BC as a tensile force. Okay. So first I will consider sum of all horizontal forces is equal to 0. That is summation f of x is equal to 0. So it is minus FBA plus FBD is equal to 0. So what is the value of BA? We have calculated it as a 15 kilonewton. Okay. So here it is minus 15 plus force in BD is equal to 0. So here you will get the force in BD is equal to 15 kilonewton. So here we got the correct value, positive. So here we will got the positive value. So the nature of force BD is tensile as we have calculated. Then sum of vertical forces is equal to 0. So what are the vertical forces? It is minus FBC is equal to 0. So what it means, as I told, if we don't have the external load acting at a joint and the two members are parallel to each other, in that case we will find the third member is, which is not parallel member, is having zero force member. So here you can see in joint B, force AB and force BD are parallel to each other, isn't it? And at this joint B there are no external force. So for this reason we got the force in member BC is 0. So likewise we have to find out the zero force member from the truss. Likewise you have to calculate for all the members. So if we apply this concept to the entire truss, here I got the force in member BC is 0, isn't it? Force in member AB is 15 and force in member BD is also 15. And force in member AD we got it as a 18.03 compressive force. So here it is 18.03 compressive force. So again if I consider the joint C, so here also I will get 18.03 and the member force in member GE also I will get 18.03 and for the force in member DF also I will get 15 kilonewton here. Okay. So if you observe the joint BD, there are no external forces acting on the joint. So for this reason we will get the force in member CD, the force in member DE as well as the force in member EF are the zero force members from the entire truss. So likewise we have to find out the zero force member from the entire truss. Now find out the forces in all the members of this particular truss. These are the answers. These are the references considered for the study. Thank you.